All right. Hey, everyone. Thank you for coming to my talk. I'm going to give a brief intro. It's kind of a meaty presentation, so I'm going to try to go through it as quickly as I can and leave some time at the end for some questions. So I'm Skyler. I'm based out of Miami, Florida. I work as the principal data architect at Entrada, and we're a boutique Databricks implementation firm backed by Databricks Ventures. We do a lot of Databricks implementation on a lot of their Databricks' biggest clients. So this talk's going to be about creating a custom data source with PySpark. It's going to be a streaming data source, and this is one of the bigger new features of Spark 4.0. It's been out in some Databricks runtimes for a few months now, but officially part of the 4.0 release. You can create batch readers, you can create streaming readers. In this case, we'll be doing a streaming reader. I'll be giving some tips for best practices around that, around Spark streaming and that kind of thing. So getting right into it. So the problem that the custom data source solves is, as we know, Spark has built-in data sources. You can read from Delta, you can read from Kafka, you can read from JDBC, CSV, you can read all these different formats. But what happens when you have a data source that isn't natively supported? Typically, it's not easy. Typically, you've got to find a third-party library. That's the easiest if you're lucky. Most of the time, they're not maintained. You might find like a 13-year-old Stack Overflow post or something like that and hope that it works. On RDDs, Spark 1.3 or something, trying to work that on Spark 3.0. It's really tough. I think we probably have all been there before. And if you can't find a library, then you have to just build your own. And most companies don't have the engineering manpower or to do that in the first place and then maintain it, keep it updated with new Spark versions. It can be pretty tough. So with this API that is launched by the launch with 4.0, it's a whole lot easier. What this does is it's available in DBR 15.3 plus. That's for stream reader, stream writer 15.2. So Spark is now going to provide you with some interfaces that you can then import into your code, and then you can implement. You can just override some of the built-in methods there of those interfaces with your own code and create your own custom reader. So once you do that, it's as simple as spark.read.format, and then you just pass your new custom reader as the argument to that. So like you would if you're reading a CSV file, spark.read.csv, that's just a data source that is already implemented within PySpark, and now you're just going to override those methods, just inherit those into your own classes, create your own data source, and then you can read it just that easily. So getting into what we're going to actually be implementing here. So we're going to be using something called Java messaging system, and for those that don't know, think Kafka, but much older. Obviously written in Java. It's a message service, so this is a service that sends out messages. So you can receive streams essentially from this. You can get notifications about changed applications, like Delta notifications, that kind of thing. Typically what you would read with Kafka, but in older enterprises, banks and whatnot that are slow moving, a lot of people still actually have this. And there's a few protocols that can read from JMS, a few message brokers, and the most popular is this Apache ActiveMQ, maintained by the Apache Software Foundation, so it's open source, but it's ActiveMQ is not supported data source in PySpark. So if you want to read JMS with ActiveMQ, you can't. Yeah, I couldn't find a third-party library. I mean, this was something that in my gig when I was implementing this, we had to write it in Java. I don't even know Java. Another team had to come in, create a Java class, essentially, to read from ActiveMQ, and then write to a MySQL table, and then we had to then, since MySQL, I would just read from JDBC with Spark, we could then read that from Spark. So just a whole huge workaround, a bunch of extra infrastructure that had to be spun up, very tedious, definitely not an ideal solution. So when I saw this in the documentation for the custom data source, the first thing that I tried to do was see if I could actually refactor that and cut out that middleman and read it straight with Spark. And I was actually able to do that, so I'm going to walk through how that works and how you can kind of apply that to maybe your use cases, or if you ever see it in the wild in the future, you'll have an idea of how to actually handle it. So what you can think, so there are ways to connect to ActiveMQ. One way you can use Python. So there's something called the Stomp protocol, which is a way that you can listen to these brokers. And you can think of ActiveMQ as, if you think of the JMS as the mail and you as the receiver, you want to get that mail, ActiveMQ is like the mailman, is the person who is the thing that delivers the messages to you. So we have to find a way to communicate with the mailman essentially to get those messages. So Stomp is one way, one protocol to do that. It's written in Python, and you can import that. You can download it in Databricks Notebook. You can just pip install it. You can add it as a cluster library, and then you can read this in Python. And you can kind of think of this custom data source in PySpark as like a Python UDF on steroids. You write your code in Python. You have a function. You want to distribute it on a Spark cluster, then you just wrap it in the PySpark UDF. It's kind of like that, except it's a little more in depth. It's much more customizable. So in this case, we're going to still write our Python code. We're going to still use stomp. We're going to still install that Python library. We're going to write basic Python methods and object-oriented programming in Python here to write our custom data source in PySpark. And so to walk you through it in Python first, so you could do this. I mean, this works. It's single-threaded, though. So if you have really low latency requirements or a bunch of messages are coming, many messages a second, you have multiple topics or queues that you want to subscribe to, Python can't really handle that. It's not really fault tolerance. It's not as good observability. You get all those things with PySpark, with Spark structured streaming. That's what we want. We want those metrics. We want the fault tolerance. So if you're stuck with Python, it's not a very good solution there, especially in an enterprise-grade data if you're dealing with that kind of volume. So first things first, you need to know how to implement it in Python, though, because we're going to follow that pattern within PySpark. So there's a connection listener class within Stomp, which it just tells Stomp how to connect to your individual broker service, ActiveMQ. And you create your own class of it. You inherit that. You create a child class. I just named it MyListener as a test here. Create your initialization, which is going to create a connection whenever you create a connection object of this class. And then you do a few things. So you have an onConnected method, onError, onMessage. These are things that happen during the states of this job, essentially. So when you connect, do something. When there's an error, do something. When you get a message, do something. So these are all interfaces that you have to implement yourself. So Stomp, when you run this, Stomp knows what to do with those methods, but it's up to you to put your own custom code in there to figure out how you actually want to handle that stuff. So for instance, the onMessage is very important, as you might imagine. You're going to get a frame back. That's why you see the frame as a parameter for all these methods. So the frame is just the message itself. Usually, depending on what Stomp protocol you're using, you get different parts of it. It's usually just a JSON payload. So you get things like the body is the actual message that you probably want to consume, but there's a lot of metadata around. There's headers. You can see there's a destination header, which is the queue that you're subscribed to or the topic that you're subscribed to, depending on your service. And then so you can do different things. Yeah, you see I'm error handling here. Obviously, this is very basic because I'm just showing you how it works in Python. But we're going to take this code and you're going to create a connection object with Stomp. And so all you have to do is pass Stomp your host and your ports. So you can pass it a list. So if you have multiple hosts and ports, like backups, if one goes down. So Stomp's going to go through that list and try to connect to the first one that it can. And if one fails, you have some fallback just in case. So it's always good to have multiple hosts and ports in case one fails. You don't want to miss any messages or anything like that. So Stomp can handle that. Then you, with your connection object, you just set your listener. So I'm instantiating my listener inside of that set listener call right there. And then I'm connecting with a username and password. So just regular username and password connection to the ActiveMQ service. And that's how I'm connecting. So now I've got this connection object that's connected to my broker. And then I've got to tell it what to listen to, though. There's different topics, different queues that are being delivered to. These messages are being delivered to those queues, we'll call them. And you can subscribe to one, you can subscribe to many. In this case, I've got a list of queues I want to subscribe to called queues. And I iterate through that list, and each queue needs a unique ID. So I just use enumerate to create a unique ID for each queue, assign that to the subscribe call here, and then you have to have acknowledgement style. So this is pretty important. This has to deal with fault tolerance. So auto mode is the most basic. So the message system, in our case JMS, has to know if the client, in our case us, receive the message or not. The client has to know some way. So with auto, it's the most basic to implement, but it's the least safe because it's going to assume if the message was sent to the client, it was received. So in our case, if we're using Spark and we're using this message mode, let's say it gets to Spark and we're doing a write, we're doing some sort of data frame manipulation on it, driver fails, something happens, a network issue, whatever. Something happens, we lose that message. So I'll show you as we get into the meat of it a little more, but in a production grade setting, you want something that's called client mode, whereas the client actually tells the messaging system that we received this message. So that's something, so each message has a unique ID. So the client, once you process it, you can take that unique ID out of that frame that I was talking about, and then you can send it back to the message service and say, hey, we received this message, take it out of the queue, give us the next one. So that's what we're going to be doing. And what we're going to do is take that Python code to connect to Stomp and connect to PySpark. So kind of similarly, we created our own custom class there based on a stomp class that we imported. We're going to do a similar thing here with PySpark. So there's a new library that you can import from, PySpark SQL.data sources, and there's a few classes that you have to implement here. So one is the input partition class. So I'm creating my own class, ActiveMQ partitions, based on inheriting from that. I'm creating a child class on it, and I'm implementing its methods here. So all these methods are in this interface. And so for this one, this tells Spark what to do with all the data partitions. So you're going to obviously distribute this. You're going to put it on different cores, different executors, and it's going to be doing a body of work. So in this case, what does each core do with that data, with that micro batch? So that's what the input partition class interface is for. And so it's pretty simple here. I've got a start offset and end offset, so I know I iterate through the messages on this read method. So on the initialization, we have the earliest offset and the latest offset. So that's how we track our messages that we've read and that we've consumed. So each message is going to have a unique offset within each partition. And then we're going to start with the lowest, and we're going to iterate through all those frames until we get to the last one, and we're going to finish with processing. Then, of course, we just have the message itself. In this case, it's a list of tuples. The tuples have offset that we're dealing with, the queue, the message, a timestamp that we received it, and an error if it had one. So that's a custom kind of object there, data object with that tuple. That's what I made. That's what I'm eventually turning into a row and eventually putting into my data frame, and eventually writing into a delta table. So I want to capture the offset. So if I look back at my bronze table, I'm going to be writing to here. I want to see what offset this message belonged to. I want to see what queue it came from. I want to see when it happened. I want to see that timestamp. And then if there's an error, I want to know if there's an error. So if there's no error, we'll see a little later the error handling, how that works. So whenever the input partition, or in this case, the ActiveMQ partition implementation of it is called, these methods are going to run. So one important thing that you'll see is this get state and set state. Actually, let's go back to the read real quick. So you see with self.lock, this is very important when you're streaming. So you have multiple threads here with Stomp. Stomp has a thread for reading new messages, for understanding when they come, and it has a thread for maintaining the messages that are already in the queue that you need to process. So when you're actually processing these partitions, you want to lock that message group. It's a list, remember the list of these tuples. You want to lock that so as you're doing that processing, Stomp is not adding more messages to it, and you get state conflict, essentially. So during this partition, that's why we're gonna lock it here. And then we're going to, for checkpointing, you can't serialize a lock. So if your message is locked, and I'm using threading for locking, by the way, the threading module. So if your message is locked, you can't serialize it. You can't write it to a checkpoint. So the first thing that's going to happen is we're going to copy that dictionary. We're going to remove the lock from that dictionary, and then we're going to return it. And then so whenever Spark is deciding to checkpoint this stuff, that's the state that it's going to use. And then when it finishes that write, it's going to set a new state. We're going to take that dictionary back, and we're going to relock it, and we're going to create a new connection. So that's what that get state, set state is, and that's what read does. So that's what's going to happen for every partition. And another class that we have to implement is the data source. In our case, there's a data source reader and there's a data source stream reader that PySpark provides for you. The stream reader is what we want to use for streaming. And as you saw before, the connection listener, that was from Stomp. So remember the Python code, I'm implementing both here. So these are both I have the child classes of both these parent interfaces, essentially. I'm doing a lot of similar stuff here. I'm doing my initialization. And in this case, you might see some familiar code here. I'm taking those same parameters that I used to connect originally in Python, except I'm now using the options dictionary in Spark. So think of it this way. This is when you use spark.read.format, you supply your custom data source, and then you do .options. So it's like when you're reading CSV, you do header option true. So this is going to do that same parsing mechanism, but in our case, we want some custom options. We want what host we want to connect to. We want the port that we want to connect to. We want the password. We want the username. And you can imagine there's multiple things you can do here. This is basic implementation of it, but if you really want to get good production grade code, you can set defaults. I mean, in my case here, I've got a default host, localhost. I've got the default ActiveMQ port, just in case there's one that they forgot to pass it when they're connecting. Of course, you want to probably do like a not implemented error or something like that. If they don't pass a password or something like that, you might want to say that, just give a message to the user that, hey, you can't connect to this if you don't give a password or if you're using SSL, that sort of thing. That is all handled here. So this is just setting that connection up and then parallelizing it with the data source stream reader. Okay. So more connecting here, I'm just adding random print statements. If I was actually doing this in production, what I'd probably do was I'd set up a Python logging, and then I would probably write the logs to a materialized place, like in a Databricks volume or something. So then you can go back and see the logs. And I'd probably definitely put logs when I connect, when I disconnect, when I subscribe to a broker, when there's an error. So then you can always go back and read, even in Spark, you'd read that log file and then go back and debug. That's probably what I would do, but here, like I said, it's a pretty basic implementation. I'm going to be doing the same concept here with subscribing to a host. In this case, in my commented out code here, that's the iteration that you saw earlier where I connect to multiple hosts. For the sake of example, I'm just connecting to a single host here. I'm using auto acknowledgement mode, but again, in a stronger implementation, you don't want to use auto, you'd want to use client side, in which case you send that message back to the messaging service when you receive it. We're also handling the get state and set state again, in case there's checkpointing going on. We want to remove the lock from the checkpoint object that's being written. You want to remove the connection. Those are not serializable. The connection it only persists within that run of the class. You can't write that to a checkpoint. Same with the lock. So that's the get state, set state again. Wrong button. So on connected, again, I mean, this is, I would write this to a log. I'm just printing it for the sake of this demo, but maybe just a nice connection message. Okay, we worked. Then the on message, this is going to be the beef of the operations here. So this is what you want to do with the messages that you're sending to a so in this case, it's determining what micro batch, like what messages are part of what micro batch, the send to that input partition interface that we implemented earlier. So I'm going to append to my internal class messages. I'm going to append this payload, the JSON payload that I got, the message itself. And I'm going to, remember in the message tuple that we were looking at, we had an offset, we had, I think, a frame body, we had the queue, we had the timestamp. This is what I'm passing. So I'm creating the current timestamp, just using basic Python datetime, setting that to Eastern time zone. It's what I'm normally on. And then I'm getting a queue name here. I'm setting I'm getting the queue name from the actual response. So I'm getting a dictionary method here to get that queue name. If it doesn't have one, I'm just writing unknown. You can do some data analysis later on that. You can just filter for unknown and see the issues there, what offset it came from, the timestamp, if there's an error, that kind of thing. And as I'm appending these messages, I'm checking to see if there's an exception. If there is exception, you can see the final piece of that tuple there. If it reads that message and appends it to the internal message object, fine, then it's none. It's just going to be null. But if there's an issue here, we actually capture that exception, convert it to a string, and then we can go back and, again, do some more data analysis. We can go back to our bronze table and filter out the nulls for the exception. And if there isn't any, if there's an exception, we'll see that, and then we can handle it from there. And then we're going to iterate the offset. So each one of these messages that we get is going to have a unique offset, as I mentioned. So that's how we're going to capture that, again, when we're going back and error handling, where our states are being handled within the partitions. It's going to understand that offset. It's going to use the offset in checkpointing as well. The checkpoint's going to know the latest offset that it read from. So if Spark does fail, if something happens and it picks back up, it'll pick back up at that latest offset. It'll be captured in the checkpoint. And then we have those other, you probably recognize these. This is from that original Stomp implementation. These are the methods I'm overriding here. So you can do something on error. Maybe, again, I would print that to a logging file somewhere on a volume, most likely. Have a message on disconnect, and setting initial offsets, and keeping track of the latest offset, setting that initial offset, keeping track of that latest offset, so we know what messages we've already seen. We don't double dip and process the same message twice. And we don't lose track we don't miss a message. We know the exact next one based on that offset. So partitions, this is a method from the data store stream meter class. This is the PySpark class method. So in this case, this is where you're going to be actually instantiating that ActiveMQ partition interface that we implemented on the previous slides. So every time we're going to create a new ActiveMQ partition with those messages. So we already filled up that message list with all those tuples. So that's what's going to be returned from here. If there is a new one, so if the end offset is less than the start offset, we know there's no new messages. We don't need to create a new micro batch. And this has to do with your trigger interval. So again, we're streaming, so you have trigger intervals here. Do you want to check for micro batches every 1 second, every 5 seconds, every 10 seconds? You can kind of tune that, and if there was no new micro batches, the offset didn't increment, so you're not going to do anything. In this case, if there is a new message, there's going to be a new offset, and then you're going to create a group of ActiveMQ partitions. And it's doing a lot. I mean, that sounds like a lot there's not many lines of code here, so it's pretty nice. I mean, Spark handles the batch sizes, it handles all the checkpointing for you, it does all that for you. So you just have to know how to just basically implement this interface, and then you're good. Spark handles the hard stuff. And then you have your commit. So in this case, my commit is pretty simple. In the case, because I'm just using auto acknowledgement mode, in the case where you use client acknowledgement mode, this is where you would implement that system that I was talking about, where you actually talk back to the messaging service and say, yeah, we got this message, we got this offset, this is the message ID, this is the subscription ID that it came from our host. So that's where you would implement it in the commit. So after commit happens, that's when the offset is standardized, this is the writing to the checkpoints. So Spark is just keeping track of the current state for commit. All right, so you're gonna set us, okay, so we're gonna skip down to the bottom here. ActiveMQ data source, this is the last class that you have to implement, so last interface. Well, my implementation is the ActiveMQ data source, but you're inheriting from the data source class. So as I mentioned, there's a data source for CSV files. There's data source for the Delta format. There's Parquet files. So in our case, my new data source, you have this name method that you're creating, this class method. I'm calling it ActiveMQ. So now what I can do, I've implemented all these methods. What I can do is spark.read.format ActiveMQ, just natively, as if it was always there. And it's going to do everything that Spark does. All that fault tolerance, all that logging, all that monitoring, all that keeping track of state is built into your program now, just from those few lines of code. I'm going to define a schema for my actual data frame, for my PySpark data frame here. And it's similar to what you were seeing just with the Python objects there with that tuple. So I've got my offset, just an integer, I've got a queue, got a message, got a receive timestamp. And if there's an error, you can see that some of these allow nulls. Of course, error allows nulls. One thing that I did think of after I already created this presentation is for the message, it's a JSON string that you're getting back. But for me, I usually subscribe to multiple different queues, and each queue sometimes has a different JSON structure. So you can't just you can't use a struct type here because it changes depending on what queue it came from. The message changes. So this is a perfect utilization for the variant type. I don't know how much you guys have seen of that for Spark 4.0, but it allows you to put structured JSON without defining a schema. So you can have different JSON schemas within that column. So it's a perfect use case for a variant type. And then you can access that JSON string as if it was a defined struct type. You can use dot notation and everything. So that would be a good use case for that. And then there's this reader method. So that's where I use a not implemented error. So this is what happens when you do spark.read.format ActiveMQ. It's a stream. So you can't read it in batch mode. So I just have this not implemented error. Lets you know, hey, use the stream reader. So that's when you do spark.readstream.format ActiveMQ. So I'm implementing a stream reader here. You could actually do both. I mean, you could technically. I mean, if you have like 2 minutes between your triggers or something like that, then you could do this in batch mode. I definitely prefer streaming because it keeps track of that checkpointing. It's much safer. It knows what it's much easier to implement to keep track of state with a stream than it is with batch. You have to kind of do a lot of your own custom code if you're using batch to manage all that. So in our case, yep, we got the stream reader method filled in here, and then this is where we actually create that ActiveMQ stream reader class that we just implemented. So that's the class that actually knows how to do the parsing of the message, knows how to connect to the broker, knows how to communicate back and forth with the broker, knows how to divvy out partitions and micro batches. So that's when, so you see when you do spark.readstream past this format, this is when you're instantiating that active stream reader class. And then when you're finally, last step here, so finally you've implemented all these interfaces, at least 3 of them. There's others that you can do. This is again, the most basic implementation of this. Then you can register that data source that we just created. So we just created that ActiveMQ data source from the data source interface, and now we're registering with Spark. So this allows us to actually call spark.readstream.format ActiveMQ, which you see on line 4 here. So now I'm not doing anything, I mean, if you saw this and didn't see the presentation and started on line 3, you might think that this is just the new data source with Spark 4.0. I mean, there's no differences here. You're passing options. You can pass a dictionary of options if you want. Just same functionality as any other streaming source. I mean, this could be Kafka, right? Pretty simple. So you can do a lot of after this, you can do any data frame manipulation that you want. So it's a streaming data frame now. You can do anything. So in this case, I'm creating a temporary view. I call it ActiveMQ messages, and I'm reading from that view. So then I'm just reading that stream in with SQL. And I've got my checkpoints. I've got saving my checkpoint to a volume. I'm having a very quick trigger processing time. Every 1 second, it's going to check for micro batches, and I'm appending those micro batches to a table. So I'm writing this all to a Delta table. I've got my table variable defined using Unity Catalog here. You have all your safety nets, all your protections, everything that Databricks gets you out of the box, you now have in your custom data source, which is, what was it, 200 lines of code, if that. And then you can look at all the metrics. Again, this is just a pure PySpark stream. I mean, you can look at all the messages, you can look at what each micro batch processed, you can look at how long it took to process them, you can see your memory utilization, you can see everything. Here's the schema. As we saw, we defined that in our reader, in the actual data source itself, the offset, the queue, the message, all that good stuff. Yeah, I mean, this probably looks really familiar to anyone who's used Spark structured streaming. It's the exact same thing. Here, you can look at the, like I said, you can look at the raw data, see which batch ID, how long the batch took to process. This is where you can kind of tune your trigger interval here. I mean, in this case, I had 1 second trigger interval. I'm only processing 2 rows. I could probably lower that a little bit. But you can see all the different offsets, what's getting committed to that checkpointing file and the volume, just as you could any other stream. And there you go. That's the actual table that I'm reading from. Itself. So I save that to a Delta table. I'm literally just reading for that Delta table, and then there you go. You got your offsets for each message. The queue, I just have this fake test queue here. And the message, I don't know if you noticed in my message tuple, I was parsing just a piece of that out, just so there's no like data breach here. So just looking at a timestamp here for my message. But typically that would be a JSON string, as I mentioned. I'd probably make that a variant data type if I could go back and redo this. And I got the timestamp for it. So you have an interactive timestamp. Most of these are not going to be the exact same. So you can do all sort of time series analysis on that. And then, like I said, with the error, if there's an error there, you want to see null there, obviously. But if there was an error, it's caught in that exception block, and it will put a string, it'll translate the error to a string, and then you can do whatever you want with it from the table. All right, I think we're right on time. So to summarize, this is a PySpark data source, custom data source implementation for reading a stream. You can actually do writers too. You can have your own writer. I haven't done that yet, but this is for reading purposes. We read an ActiveMQ stream using JMS protocol, and we did it in about 200 lines of code. And we saved ourselves the headache of creating our own custom library, of maintaining that, yada, yada, yada. In this case, what I'd probably do, I'd probably just save this to source control somewhere, my version 1, once I do all those enhancements that I mentioned. I'd save that, and then I'd probably just create a wheel file out of it, and then I would just install that wheel file in my cluster on my job, and then you could just use that in a notebook. That's probably if I actually productionize this, that's probably how I would handle it. So that would probably be my recommendation there. But yeah, now we got this seamless real-time data integration from a source that Spark had no idea how to read, never heard of, created way before Spark was, and we got full observability, testability, scalability, everything that Spark gives you, auto-scaling, whatever you need. And we're using Delta format, perfect for our Delta Lake, for our lakehouse. Safe, the threads are safe, we're locking, we're reading our micro batches, keeping track of state, keeping track of our checkpoints, that easy. All right, guys, I guess do your surveys. Yeah, thanks, that was the demo from Entrada.